Good morning, everyone. This is Julie McDonald with Microcom Technologies, and I'd like to thank all of you for attending today's webinar with MetaGeek. Today's host is Casey Cathy, and he is their Customer Experience Specialist and will be presenting today. If anyone has any questions, please submit them in the question box, and Casey will answer them at the end of today's presentation. Casey, thank you so much for being with us today. I appreciate your time and looking forward to your presentation. I'm finished for now. Please go ahead and take it on over.
All righty, awesome. Thank you very much, Julie, and I appreciate being here. Thanks for joining everyone today. Today I'm going to be talking about a few of our products here, and I'm going to try and focus on product selection. So I'm going to try and talk about some jobs to be done and kind of the various occupations that people would use our tools for. And so on the agenda today, I'm going to introduce myself, talk just a little bit about MetaGeek, go over some Wi-Fi fundamentals, which are very important to understand our tools. So I'm going to kind of go over the basics a little bit. And then we're going to talk about our products that Microcom has to offer. And the first one we'll talk about is Chanalyzer, which is the deep dive into spectrum analysis. And this is a tool that, this is kind of the bread and butter of MetaGeek. This is a tool that I see a lot of our custom home and AV installers use, because you can kind of record over time, and I'll go into more detail of that a little bit later, but this is a great tool for spectrum analysis and Wi-Fi scanning. I'll talk a little bit about Wi-Fi Air, which is a fairly new product of MetaGeek, and this one is kind of the same thing as Chanalyzer, the same jobs to be done, but the benefit here is that it works on an iOS or Android device, works on your mobile device. And I'll go ahead and demo that at the after this presentation as well, to kind of show you what that has to offer. And then finally, the next tool is a little bit more of an advanced packet analysis tool. It's called Eye P.A, and the P.A stands for packet analysis. And this one is a little bit more, the first two tools like Chanalyzer and Wi-Fi Air aren't able to solve the Wi-Fi troubleshooting problem. Then you kind of want to bring out a tool like Eye P.A to really kind of take a look at that packet conversation between a client and an access point. And then of course, we'll go ahead and open up the floor for any questions if we have them. So a little bit about me. My name is Casey. I'm the CX specialist here at MetaGeek. So if you send in a support ticket to support@metageek.com, chances are I'll be the one to answer that, to see it first at least. I have a few certifications put on by the CWNP program, which I highly recommend checking out to further your knowledge on Wi-Fi. And then of course, you can find me on Cathy_5 on Twitter. There's a really great community of Wi-Fi experts on Twitter, so I recommend checking out the people that I follow on this account, because if you have any questions, they're usually really open about answering good questions about Wi-Fi. So a little bit about MetaGeek. We're based here in Boise, Idaho, and this is a picture from our downtown office. However, I'm currently working from home. We all are working from home, so hoping to get back in this office shortly and hope things get back to normal here soon. Let's jump right in, just to talk a little bit about the two bands that the FCC currently allows Wi-Fi to operate in. We're going to have a 6 gigahertz band here pretty soon open up for us, but right now it's just the 2.4 and the 5 gigahertz band. Of course, this is probably pretty basic for a lot of you guys, but it's pretty important to understand. This is what our software displays, and this is what we perform spectrum analysis on and things like that. So these are the two bands currently that we work with. On the 2.4 gigahertz band, it has a little bit longer of a wavelength. And so it can kind of go a lot farther. In general, it has about a 300-foot indoor range. It pierces through walls a lot better. And because of this, it's actually usually congested with Wi-Fi. You're going to see your neighbors' 2.4 gigahertz radios travel pretty far. You're going to see their networks a little bit before you see the 5 gigahertz networks. And it's also plagued by non-Wi-Fi stuff as well. Cordless phones, baby monitors, Xbox controllers, things like that, Bluetooth devices. These are all, non-Wi-Fi interferers that can actually cause problems in the 2.4 gigahertz band. Also, there's only 3 non-overlapping channels in the 2.4 gigahertz band. We actually only have about 60 megahertz total to work with, from the very left corner of channel 1 to the rightmost corner of channel 11. And this is US only, by the way. In other countries, we do have channel 13 that also doesn't overlap. But in the United States, only 1, 6, and 11 are the only free 20 megahertz channels that don't overlap with each other. Therefore, these are really the only 3 channels you'd want to select. And our tools will let you know, which channel is the most clear here to choose. And then in the 5 gigahertz band, we have 24 non-overlapping channels, so a lot more room to breathe here. The problem with the 5 gigahertz band is that it's a little bit of a smaller wavelength. And so it kind of has a lower indoor range, about 90 feet, and not all devices are compatible with the 5 gigahertz band. Cheaper cell phones, cheaper laptops, things like that, they'll kind of, in order to save costs, they'll only have a 2.4 gigahertz band chipset. So not all devices work in the 5 gigahertz band, and so you kind of have to be aware of that as well when deploying a network. Just a quick kind of note about some of the standards and the history. The real takeaway here from this slide is the modulation scheme and what that looks like with the spectrum analyzer. So if you have a tool like the WiSpy DBX and you're performing, spectrum analysis in either the WiSpy Air or Chanalyzer, if you see this DSS modulation scheme, it's going to look like a curve shape, kind of like this with a spectrum analyzer. And then you know that these lower data rates are being used. Anything 11 megabits per second or lower, are going to be used if you see that kind of curve shape. And a lot of networks beacon at these lower data rates, send out beacons and probe requests and things like that. And so you'll see this kind of light blue shape if it's beaconing. You'll see network activity look like this. Once you see this OFDM modulation scheme, which stands for orthogonal frequency division multiplex, this looks more like a haystack. It's more like a square shape, kind of like this. And then you know that some higher data rates are being unlocked, and this network is performing at a bit of a higher performance, so to speak, that 54 megabits per second or higher being used. And again, this can be either 20 megahertz wide, 40, 80, 160 megahertz wide. So it can get pretty large too, depending on what you choose to deploy your network with. So that's just kind of what those look like. It's really important, again, to have some sort of Wi-Fi scanner and spectrum analyzer in order to see the types of Wi-Fi interference. And just a quick note on Wi-Fi interference specifically. Co-channel interference is when your network and other networks share the same channel. We'll say like this is channel 1, for instance. This is actually more preferable to adjacent channel interference, where maybe you have a network on channel 4, and maybe you have a neighbor network here on channel 5, and maybe you have another neighboring network here on channel 6. This is actually, co-channel is more preferable to adjacent channel because Wi-Fi devices are more polite when they share the same channel. It's just kind of baked into the Wi-Fi protocol that if it sees another Wi-Fi device on a channel, it's going to wait its turn to talk, whereas adjacent channel devices, they kind of start yelling over each other in order to hear the access point, in order for the access point to hear the clients. And it's pretty much the noise floor starts to raise, and you'll see this noise floor in terms of spectrum. If you have a spectrum analyzer, you'll see kind of a higher noise floor if you have a ton of adjacent networks, just because they're yelling over each other to some extent here. So it's really important to have a tool that can see this. Furthermore, it's important to have a spectrum analyzer specifically in order to see non-Wi-Fi interference, like I talked about earlier, cordless phones, baby monitors, things like that. You really have to have a spectrum analyzer to catch that activity, and this graphic really demonstrates this well. This is just a basic picture of a Chanalyzer without a WiSpy DBX plugged in. It's just showing you, networks around you, Wi-Fi networks, things like that. You really don't have a good idea of actual utilization on a channel. So here with the spectrum analyzer or WiSpy DBX plugged in, you can see that there's some sort of interference here, just wreaking havoc on channels 11, and the shoulders of it even dip all the way into channel 6, and ultimately raising the noise floor on the entire 2.4 gigahertz band here. And you'd have no idea this was going on without a spectrum analyzer. So that's why, I always say it's really important if you're deploying Wi-Fi networks at all, which is probably what most of you guys are doing. It's really important to have some sort of spectrum analyzer under your tool belt. Just highly critical. You have to see what's going on the bands. Even as a home user, I think it's important. For me, sometimes I'll be using the Wi-Fi on my home network, and it's so nice to bring out a spectrum analyzer to kind of see what's going on. And oh, it turns out my neighbor is using the Wi-Fi quite a bit because of the spectrum is just lit on that channel. Really important to have. Just a quick note on Wi-Fi coverage. We tend to strive for about negative 67 dBm signal strength here at MetaGeek. We really like this number. It tends to be a pretty reliable number. If you have at least negative 67 dBm throughout your household or the environment that you're deploying Wi-Fi for, you should be in good shape. And our tools will display the signal strength of your network and neighboring networks. So you can check for these Wi-Fi dead spots and things like that. As soon as you start to drop below to -70, -80, you're going to start dropping some frames. If you're in the middle of a Google Hangouts meeting, the video might lag, audio might start getting kind of laggy. And if you're a little bit higher than -67, about -30, that doesn't really mean too much more in terms of speed. -30 means you're basically right next to the access point, and it's not necessarily better or desirable. Again, -67 dBm is kind of that sweet spot to kind of have it throughout the environment or throughout the household, and to encourage good handoff as well if you're deploying multiple access points. So Chanalyzer, kind of to segue into that, again, it's a deep dive into spectrum analysis. It's great because you can locate sources of interference, which I'll demonstrate if you needed to find some sort of non-Wi-Fi interference. We actually have a directional antenna that Microcom does sell with the Wi-Fi DPX and the Chanalyzer Essential bundle. Basically, it replaces the omnidirectional antenna like so, and then you can replace it with this directional antenna to help you kind of locate where it might be coming from. This is handy if you really don't have any idea. Maybe you've never been to this environment before and you don't have any idea where anything is. If a cordless phone is somewhere, and I've heard some really crazy stories, like in the ceiling they had like an access point, or some sort of interference device that they had no idea was in the ceiling until they used this tool to kind of locate it and then remove it, which would help the Wi-Fi. Chanalyzer is great to find Wi-Fi dead spots because, again, you get the signal strength of networks, and so it's pretty easy to walk around and kind of keep an eye. These are just hovering at certain signal strengths. As you get closer, it gets taller. As you get farther away, it gets shorter. And so you can kind of imagine an invisible threshold of -67 dBm here. We'll say maybe this is -67 dBm at this line right here. And so of course you kind of just watch all of your access points and all your networks and make sure they stay above that line, or at least one is above that line at any given point. So it's pretty handy for that type of job as well. The really important, valuable feature here of Chanalyzer is that you can rewind or fast forward your spectrum data. And it basically records as soon as you open up the software. And so this is a great tool to kind of, you can send your recording to someone else to troubleshoot. You can send it into MetaGeek support team and I can help troubleshoot it. I can glean a lot of information from these recordings that get done in the waterfall menu here. This is probably one of the coolest things about Chanalyzer is that you can build pretty professional reports. It comes pre-stocked with literature, and so a lot of people, especially custom home installers, AV installers, they will actually use these reports to hand them to the customer, whether it's someone who owns a house that needed good Wi-Fi and needed their Crestron and Zigbee equipment to work well. Whether it's a network admin that needs to kind of prove that they deployed a healthy Wi-Fi network throughout the environment. There's a lot of use cases for these reports, and they're very useful in general and make you look very professional. We also do, at least Microcom does sell a Cisco Clean Air accessory. This helps you kind of remotely view the spectrum and Wi-Fi data from a Cisco access point that supports the Clean Air module. So we do have that available as well if you happen to deploy Cisco access points. Again, it's really important to kind of have a spectrum analyzer because, like I said, with co-channel interference, each Wi-Fi device will actually wait its turn to talk until the interference here, whether it's a microwave, cordless phone, baby monitor, what have you, all these Wi-Fi devices think that this is a Wi-Fi device. Even though this is a leaky microwave here in the 2.4 gigahertz band, Wi-Fi devices really don't know any better, and so they'll just wait their turn. They're very polite. They'll wait their turn until this microwave is done talking on their channel, or until your burrito's finished microwaving, and then they'll continue to use the Wi-Fi network. But that's why it's really important to have something to take a look at it. This is what a baby monitor looks like in Chanalyzer. It hops from one channel to the other. It goes from channel 6 to channel 9 to channel 1. So that can be really frustrating as a network administrator to have devices that frequency hop. Bluetooth frequency hops as well, but it's usually so fast that it doesn't interfere with Wi-Fi. This is what a lot of Bluetooth looks like if you're performing like a file transfer and you have a lot of Bluetooth devices. Typically, it doesn't affect the Wi-Fi, but with enough Bluetooth, it certainly will. And then this is an old wireless video camera. This one's still fun to kind of show what they looked like. You don't see a lot of these in the wild anymore because they did wreak havoc. These have been largely replaced also by Nest cameras and kind of Wi-Fi cameras. And they still are very kind of bandwidth heavy. They're still going to have this red color. They're just going to be more of a Wi-Fi signature because they're on the Wi-Fi network. So it'll be more like that square shape or that curve shape I was drawing out earlier. And so with that, I'll go ahead and demonstrate Chanalyzer and kind of show a few few important parts and why you might want to choose this tool, at least for spectrum analysis and Wi-Fi troubleshooting. So when I first open up Chanalyzer, it starts sweeping the 2.4 gigahertz band only. And so to kind of sweep both bands, I go to Wi-Fi at the top here and I select dual band. And this will dedicate the resources of the Wi-Fi DBX to the 2.4 and the 5 gigahertz band. And yeah, it looks like I have some interesting spectrum activity starting to populate. I'm going to go ahead and let it kind of populate a little bit more. And while the spectrum's starting to kind of populate, you can switch to the 5 gigahertz by clicking in this arrow in the top left corner. And so here you can actually see the 5 gigahertz access points and spectrum. I'll go ahead and go back into the 2.4 here. And the first thing, while we let some of the spectrum data kind of populate, the first thing I like to take a look at here is the networks table. So if we're looking at this from a Wi-Fi scanning perspective, this little networks table tab is a great starting point. So right now I have a check mark placed next to all my networks, and I can remove that check mark by unchecking this kind of master toggle here. And maybe I just want to focus on the Cathy-Fi network specifically here because that's the network that I currently am using and the network that I have, right? So I'm just going to place a check mark next to that, and now I kind of get to see my two access points. I indeed have a radio that's really close to me. You can see it here at negative 35 dBm, kind of hovering right here. And then I have an access point out in the studio out back here, and it's about negative 80 dBm. And so you can kind of see that these are just kind of going up and down. I'm tethered to my desk, of course, but if I were to walk around, you would see these kind of shapes either lower if I got farther away from them or get higher if I got closer to them. And one thing to keep in mind that's really helpful is this networks graph here. This basically plots out the signal strength over time. And this is really handy, again, for checking for Wi-Fi dead spots. So at this point, you know, if you had your network deployed already, again, I always like to kind of draw an invisible threshold, kind of at about negative 67 dBm, which is about right here. And you know, if I had multiple access points, which a lot of people do with, you know, depending on your environment or the household, I would just make sure that you have at least one access point above this signal strength, right? You need to have one access point above that negative 67 dBm threshold. And right now I'm also looking at both the 2.4 and the 5 gigahertz beacons. If I wanted to just, maybe I just want to focus on the 2.4 gigahertz radios, I can actually go into physical mode here, which kind of breaks apart each radio. And so at this point, maybe I just want to look at my 2.4 gigahertz radio. So I'm going to only place a check mark next to these radios and then go to the networks graph, and then I can see just my 2.4 gigahertz radio. So you can see with the tool like Chanalyzer, you really get to pinpoint exactly what radios and access points you want to troubleshoot and look for, you know, dead spots for. And then maybe if I was done, you know, looking at my 2.4 gigahertz band or doing a survey with the 2.4 gigahertz band, maybe I want to look at my 5 gigahertz and see what's going on there. So I actually only have, I think I can only see one because, again, the 5 gigahertz beacons don't travel as far. So my studio out back, I'm just not able to see it right now from where I'm at. But here's my 5 gigahertz beacon, which is right across from the hall for me. I would expect my other beacon, it's probably at around negative 90 dBm or so. I just can't see it. Sometimes I can, and it's kind of fun to see it kind of show up here at the very bottom. I'll kind of see like my 5 gigahertz beacon kind of show up here and then kind of stop, just because it, you know, I can't always see the beacon with this Wi-Fi adapter that I'm using, this Broadcom Wi-Fi adapter. I'm just a little bit too far to see that 5 gigahertz beacon. So you can see it's a great tool to check for you know, Wi-Fi dead spots and things like that. But really, you know, what this is really intended for is spectrum analysis. So I'll go ahead and go to this utilization section here and kind of beef it up a little bit so you can kind of see what I'm going to do next. Let's just say that we had some sort of intermittent interference. So I'm going to go ahead and apply some interference here, and I'll show you kind of what Chanalyzer, where it really kind of starts to shine here. So I just plugged in this this source of interference, and pretty quickly you can kind of see something starting to happen right here. Kind of a little spike shape. Oh, looks like it. Yeah, should be good. Little spike shape. You can kind of see on the left-hand side, you can see this kind of waterfall navigation. You can see something starting to appear over here as well. And looks like it's transmitting, yeah, it's transmitting pretty full power here. I'm going to bring it a little bit closer so you can kind of see what's going on. And let's just say this is intermittent. Let's just say this is one of those pesky issues that isn't consistent. So I'm going to go ahead and remove this source of interference. And I hear this a lot. I hear about people saying, you know, oh, at 3 p.m. The network goes off and everyone's devices drop from the network, and they have no idea why. This is where you really need a tool like Chanalyzer, because it kind of captures that information over time. And so I just removed that interference, and let's just say, it's still captured here. What's really cool about Chanalyzer is, you can move these time span bars anywhere you want. So this was before the interference. If I want to see exactly what was going on, I can actually just click and drag around that interference and see what was going on. And this is really cool because I'm basically paused in time, kind of like that DVR I was talking about earlier. It's, you can see exactly what's going on. And kind of pause it and troubleshoot it and say, okay, what the heck is this thing? Something just happened for about, 40 seconds, it looks like. And with Chanalyzer, you can actually go to the interferes tab over here, kind of at the left-hand side, and you can actually start to kind of figure out what this might be. And you can actually click up and kind of drag these signatures up over and kind of help identify what it might be. So in this case, it's clearly not 802.11b activity. This is kind of that DSS modulation scheme that I was talking about earlier. So it's clearly not that. It's not any G activity, although you can kind of see some GN activity over here on channel 11, probably from my network. You can kind of see that square shape, very light over there, light blue. Is it an AV transmitter? You really, it's not really an AV transmitter because it doesn't have those two spikes on the shoulders. It's kind of fun to kind of see what these signatures look like. This tool is certainly great for learning what some signatures look like. But really, this is supposed to mimic an RFID reader. So maybe you kind of pull this up and you say, oh, it must be something like this, an RFID reader of some sort, or some sort of device like that. A lot of them kind of look similar. They have this kind of spiky shape like that. And so maybe you have an idea of what it is, but you still don't know where it is. And so maybe it kind of hops back on here intermittently. So I'm going to go ahead and introduce this interference one more time here, and then I'm going to go into kind of real time here. And I'm going to put my time span, which is currently at 42 seconds. I'm going to go and drop it down to like maybe the last, 30 seconds or so should be fine. And so a really great aspect about Chanalyzer is that you can try and locate this. And so with the device finder feature, you kind of select and drag around it and click device finder. And you can actually at this point kind of clean up your selection. You hit the check mark here. And at this point, you play hot or cold with the signal strength. And so at this point, if you get closer to the device, that blue kind of line goes up. And if you get farther away, so I'm going to attenuate the signal here. If you get farther away from the device, it drops down. So this would mean I'm getting farther away from it. And then of course, as that blue line goes up, I'm getting closer to it. So maybe I was able to use my directional antenna that comes with the Chanalyzer central bundle, and I was able to find it. I'm basically on top of it at this point. And let's just say I kind of removed that source of interference. So I'm going to go ahead and remove that right now. And let's just say that maybe we wanted to build a report that kind of showcase what we did here. The first thing to kind of keep in mind is when you enter Device Finder, it creates a new session. You have to remember that everything's getting recorded. And so you can go to your session manager to kind of see what happened here. So the very first one that we did was this full 2.4 gigahertz band session. And sometimes you have to click it twice here. And so here, maybe we wanted to show that this interference was pretty bad at this point. And if you go to the networks table, if you notice here at the networks table, I'm going to go back in a logical mode. There aren't any networks on channel 6. And I'm looking right here at this channels table here. And what that basically means is any networks that were on channel 6 essentially got knocked out, right? They're happening about right here. They were just this source of interference basically knocked out those beacons. So if I had any neighbors who were using the Wi-Fi network during this 40 seconds, they probably got disconnected from the network if they were on the 2.4 gigahertz band. And so maybe I want to showcase that. And so the report builder accessory is great for this because you just go to, report builder, new reports, and maybe I want to add the density graph here that shows that interference. And this is pretty neat because it actually kind of pre-populates the literature. And this is a good point to kind of explain the colors as well. So when you see blue with the Wi-Fi DBX, that means that less than 10% of the spectrum is being utilized. So blue is a lot like a clap. It doesn't really interrupt my conversation. I can continue using the Wi-Fi. You can still hear me okay. Green means 20% is used, yellow means 40%, and then red means over 50% of the spectrum is being utilized. So red is a lot like an air horn. If someone were to come into my office and start, blaring an air horn, I would have to yell for you guys to hear me, and it would interrupt our conversation completely. And that's pretty much what happened here with this source of interference. That's a lot like an air horn. And so it's kind of cool that you can provide this for the customer. And what I also want to add here is a networks, let's do a networks table. This networks table here shows that there's only like a handful of networks, right, on channel 1 and on channels 11. Everything else got knocked out, so I kind of wanted to show that. Then we went into device finder mode and we were able to find that device, and now we're currently on the 2.4 gigahertz band after removing that device. And maybe I want to show that this is nice and cleaned up at this point. I'm going to use a wider time span to kind of show that there's no spectrum issues here. Last 2 minutes looks pretty clean. The networks table here, there should be a few more networks here. Let's see here. Yeah, well, I'm not sure where those networks went, but there should be a couple more. Let's go back to live here. There they are. Let those networks kind of populate a little bit more. We have this new network here on channel 5. We got some more networks here on channel 6. So there's some breathing room here. There's some more networks here that are able to breathe a little bit more now that we removed that interference. And maybe I want to put that in a report as well. So I'm going to go ahead and add just another density graph. Basically, whatever the time span bars are selected around, that's what gets entered into the graph. And you can customize this stuff too. So if I don't want all this information, since I already basically had that information, you can really customize this stuff. And so now I have that density graph that shows after I removed the interference. And let's add that networks graph one more time to kind of show, actually not the networks graph because that's the signal strength over time, but the networks table, and kind of show that healthy network. So I'll go ahead and maximize this report to show you what I basically built out here. So it's all kind of, comes up with the date and everything, really pre-populates a lot of stuff for you. It shows that what the 2.4 gigahertz band looked like, and of course you can put the 5 gigahertz too if you want to show that 5 gigahertz band was healthy. Shows these networks that were pretty kind of wiped out because of it. And then I removed the source of interference, so it's nice and clean. All we see is that light blue, which means about less than 10% of the spectrum is being utilized, which means plenty of time to talk. These Wi-Fi networks shouldn't have any issues at all. And then of course now we see these networks here on channel 6 and channel 5 that are allowed to breathe again after we remove that source of interference. So that's kind of mostly what Chanalyzer has to offer. This is a very, very professional tool. Again, custom home and AV installers, you absolutely have to consider this tool. And you can save the report to work on it later. You can print it as a PDF, whatever you want, but we'll go ahead and not save that. Again, for the custom home installers, we also have a pretty nice little Zigbee channel view here. So instead of Wi-Fi channels, you can kind of see the Zigbee stuff going on. So, Zigbee 11 through 2026 or so, just to make sure, your Zigbee devices aren't interfering with the network as well. So yeah, there's a lot of good value here for custom home installers, network admins. This is pretty much, at the very least, this is a good starting point for pretty much anything. It kind of handles pretty much everything in the Wi-Fi industry. So a very good tool to start with if you have a Windows device, right? And that kind of leads me to my the next product I want to talk about. Maybe you don't like using a laptop for Wi-Fi troubleshooting. If that's the case, then you have to consider the Wi-Fi Air if you prefer to use your mobile device. This has been a pretty great tool. This actually took off pretty well for MetaGeek here, and Microcom offers this device as well. But this is the actual Wi-Fi Air right here. It's just the kind of an external spectrum analyzer and Wi-Fi scanning device that basically is paired with the Air Viewer application, which is available on iOS or Android. So it should cover most of your mobile devices. Of course, it's a lot like Chanalyzer in the sense that it's going to provide all these Wi-Fi networks and what channels they're on. It's basically a Wi-Fi scanner, but it also has a spectrum analyzer in it and a packet capture adapter. The packet capture adapter we use to basically grab client details, which is pretty neat. With the client details that comes a really cool roaming history, and this is something Chanalyzer does not offer. So if you really need to kind of pinpoint roaming roaming issues with the client, I'd highly recommend Wi-Fi Air. For instance, this device in the screenshot here went from an access point from channel 18 to an access point on channel 153, and then it looks like it steered down to the 2.4 gigahertz band, and then roam to another access point here on channel 11. And so pretty cool to see that type of perspective, and that's gleaned from the packet capture adapter that we have built into the Wi-Fi Air. We also have the ability to create network snapshots. So Wi-Fi Air is a great tool for internet service providers who kind of deploy technicians to customer sites. This is great for network admins, again, who kind of need to verify coverage throughout an environment. Basically, you walk around to each room. So this one, I was taking a snapshot in Casey's office. It just got disappeared here, but and then once you take that snapshot of Casey's office, you go into the master bedroom and take a snapshot. Or if you're in an office, you go into the CEO's office, and you really make sure that that one has good signal strength, right? And you can kind of prove that and send that up to what we call Rampart, which is my.metageek.com, which is just kind of a central place where all this data goes to. So pretty neat. There's a lot of options here. This is a screenshot of what my.metageek.com looked like. We're working on the design of this by quite a bit. It looks a little bit different, a little bit better now. But basically, you get the signal strength in each room, and you get the utilization as well. And you can kind of see stuff over time. So if the Wi-Fi network changes, or the CEO says, hey, what the heck, my Wi-Fi is not working well, you can go back there and take a snapshot and see what changed. Maybe you'll find that a neighboring access point was deployed right next to them, or maybe, who knows what you'll find. But it's nice to have that historical analysis here with the tool like Wi-Fi Air and my.metageek.com, which we're kind of calling Rampart at this point. The competitor for Wi-Fi Air is certainly the NetAlly AirCheck, the G2 specifically. I think they came out with a newer model here soon. But the kind of just to go some pros and cons here, the biggest thing is the price point, and this is actually a little bit cheaper now. I need to update this slide. Microcom should be selling this for about $8.99 at this point. But the AirCheck G2 is about $2 to $3 grand. It gets a little bit higher than that if you start getting the accessories and things like that that they want you to get as well. So the price is a huge thing. Another kind of good point is you already know how to use your mobile device, right? If you have an iPhone, you know how to use it. If you have an Android device, you know how to use it. It's just an application in the App Store, Google Play. So you don't have to kind of learn how to use a new piece of hardware. And I've heard that the interface is pretty clunky over here for the AirCheck G2. It's kind of not very intuitive or user-friendly. One thing I should note here is that the AirCheck G2 doesn't have an AX chipset in it. And I think that's kind of important to realize that, you're buying a $3,000 device with possibly, just an AC chipset. Whereas the Wi-Fi Air will be able to display AX networks. I think they both will be able to display AX networks, but it's something to consider that it might kind of be, a little bit out of date at this point. And maybe their newer version kind of solves that. I'm not sure. Well, it looks like my mouse just died here. Let's see if I can get this back up and running. Well, I apologize. 1 second. I got to replace the batteries on my mouse. It looks like it just completely died on me. There we go. Let's hope these ones do a little bit better. All right, and wanted to continue on this. The Wi-Fi Air and the Air Viewer application gets regularly updated, whereas I don't believe the AirCheck G2 gets any updates. Another thing to consider, this was interesting as I was researching the AirCheck G2, you have to be associated to the network in order to see client details like roaming history and things like that. Whereas with the Wi-Fi Air, you actually don't need to be associated to see nearby clients. You can even see your neighbor's clients. You don't have to actually be authenticated and associated to the network. So that's pretty, I thought that was pretty interesting that they had kind of that restriction. And let's see. Oh, geez, my mouse is just dying like crazy. I guess these new batteries weren't much better. Well, let's see here. Let's see how I can. I'm going to probably have to move my laptop a little bit closer. I apologize for the delay, everyone. Let's just use the trackpad here. All right, I'm using a trackpad, so I apologize if my drawing is not as neat as before, like it was before, right? Lastly, the last point I want to make here is that the AirCheck G2 does have RJ45 ports, which are basically Ethernet ports. And so at this point, basically, you know, we focus on the Wi-Fi medium here at MetaGeek, so we don't have any sort of Ethernet checking or anything like that. And so again, we don't really have anything that can compete with wired checking. So if you do need to check Ethernet cables, then I recommend maybe going with something like that. I'll go ahead and demo this real quick for you guys and kind of show you what this looks like. And my favorite device that I'm using here is an iPad. And I prefer to use the iPad because it has really great screen real estate. Let's see if I can get it pulled up here. Hopefully you guys can see this. Let's see here. There we go. So yeah, like I said, I'm using an iPad here, which, you know, again, it looks a little bit better with the application. And the first thing, you know, that AirViewer kind of displays, again, very similar to Chanalyzer, is your networks, right? So here's my Cat5 networks, my 2 radios. And this is pretty great. Again, remember, this is on a mobile device. This would work with your iPhone, your Android device, or things like that. So getting this kind of just even analytics, seeing, you know, the 2.4 gigahertz spectrum, and you can switch to the 5 gigahertz spectrum here, is pretty neat, needless to say, on a mobile device. And you can dive into this card and troubleshoot signal strength over time. Very similar to how I was kind of showing you with Chanalyzer, where you can kind of draw that invisible threshold at -67 dBm. So again, you can check for signal strength. I'm able to see, you know, my 3 radios that I can see. My studio out back, again, I still can't see that 5 gigahertz beacon, but it's there if I were to get closer to it. What's really cool is I can see what band I'm on specifically. So this little chain link icon kind of to the left of my MAC address here, you can see that that's the radio I'm associated to. And if you look at channel, I'm on channel 42. Therefore, I know I'm on the 5 gigahertz band. That's really valuable because if you know with Apple devices, really all you get is this, you know, okay, cool, I'm on the Cat5 network and I have 3 bars and it's locked, right? That's kind of the extent of Wi-Fi data that you get that Apple allows you to see. You don't know what band you're on. And so that's what's really cool about AirViewer, is that I can see what band I'm on. I'm on the 5 gigahertz band, and I can dive into this 5 gigahertz radio, and I can actually see any other clients that are on the radio. So right now I actually just see one other client on this radio, which is, you know, kind of fun to look at as well. And I can see the signal strength of this client, which means I can actually track this client. So if you didn't know where a client device was, you could use this tool to essentially find it and locate it. If this utilization were a little bit higher, right now it's just showing 2%. If that were maybe 40, 50%, it's talking a lot on my network, it might be worth kind of finding that device and figuring out what you need to do with it, whether turn it off or tell the person to stop streaming Netflix or something like that, because it's you know, maybe eating up all the utilization on the network or something like that. So pretty great to get this kind of network kind of details And then kind of right now I'm in the network section down here in the bottom left. You can also go to channels view in the kind of bottom right. And this will kind of list out and show the spectrum. And so if I want to dedicate the resources of Wi-Fi Air to spectrum, I'm going to turn networks off, which will get rid of those kind of ziggurat shapes. And now you can actually see at this point, you can see the spectrum. I really like the spectrum analysis on this. You can see kind of some activity here on channel 11. Again, I can't really, I have to kind of reach over to use my drawing tool here, but here on channel 11, you can kind of see this DSSS modulation occurring. And I'm gonna go ahead and introduce that same interference from earlier, that Chanalyzer kind of RFID reader. And you'll see just how quickly, you can just see that immediately starting to show there on channel 5. Pretty obvious that there's something there. Just in case, again, just in case my networks or my neighbors are using the Wi-Fi network, I'm going to remove this source of interference. And yeah, and there you can see it kind of disappears. So very fast, very responsive. I've actually been really, really happy with the spectrum analysis of this device. There's a channel or a video on YouTube right now of me tracking a noise floor with this Wi-Fi Air, and I'm on a hike, and I found a really elevated noise floor, and so I'm literally hiking with a Wi-Fi Air and an iPad. That's how lightweight it is. I'm in like the mountains in Boise here, and tracking this noise floor, which ended up being these antennas at the top of the hike, but just super lightweight, super great to be able to kind of use this stuff. A lot of people will bring this tool out before anything else, right? Before they break out the laptop or, even open up their backpack and get their tools out, because it just does everything kind of all in one. And again, you can kind of toggle what devices or what channels you want here in the settings. And so if you know that you have a for me personally, I only have a network on channel 42 and on channels 11, so that's why I only have these ones toggled. But maybe you really just wanted to focus on, Uni 3 or something like that. You could toggle everything else off and then go back into it. And then the resources of the Wi-Fi Air are now dedicated to those specific channels. So now it's going to start channeling just Uni 3, right? Channels 149 through 165. And I don't even think I have any networks over there, so I'm just kind of doing some basic spectrum analysis. Looks like something's over there because I'm seeing a little bit of some spectrum. Yeah, kind of fun to be able to do that. And then as well, the snapshots is a pretty great option as well, which you do have to have an account at my.metageek.com, but at this point you can basically take a snapshot of each area in your environment and kind of pull that data up to the cloud. So that's Wi-Fi Air. Again, really great kind of tool to bust out before lugging out the laptop. A lot of Wi-Fi professionals, even people doing very, very large enterprise grade deployments, will oftentimes bring this tool out first to kind of get an idea of channel planning and things like that. Because again, if you have those channels kind of locked in that you want to use here, let's see here. Let's go ahead and try some different channels here. Yeah, basically it's a pretty good tool for channel planning as well, to kind of figure out, make sure there's not any sources of non-Wi-Fi interference, because it's really important to kind of keep an eye on the spectrum and make sure it looks clean as well. And again, sometimes you can really kind of troubleshoot what's going on with just a spectrum analyzer and a Wi-Fi scanner. So definitely recommend checking this tool out if you prefer using a mobile device, and if you kind of need something that's a little bit quicker to kind of get the job done rather than getting a laptop out and opening up the software and things like that. So the next tool that I kind of wanted to talk about is a little bit more advanced. So far we've really been looking at layer 1, which is kind of the physical layer, spectrum analysis and basic Wi-Fi scanning. The next layer is what we call the packet layer in the OSI model. And this is where a tool like Eye P.A comes into play. Kind of a more dedicated packet analysis tool. So while spectrum's kind of showing us the sum of all activity, in this top picture, we don't really know how many networks or how many devices are talking. This could be one really chatty device running a throughput test, or this could be 20 devices. We don't really know until you dive into the packet layer and show that actual kind of detailed conversation where you see each client device by MAC address and you see which access point they're trying to talk to and vice versa. Again, it's really important to understand that Wi-Fi is half duplex. Only one Wi-Fi device can talk on a channel at a time. This is really important when it comes to data rates, and IPA will show you these data rates. So if you have a really slow device on the edge of a network, say transferring at 1 megabit per second, maybe this guy's checking email, all these devices that are closer to the access point, maybe they can transfer at 54 megabits per second. They still have to wait their turn to talk until this kind of slow device finishes up its conversation with the access point. And IPA will show you these data rates in kind of really nice graphical columns so you can see what type of data rates are being used on your network. And if you find that you see a lot of 1 megabit per second or 2 or 5.5 kind of lower data rates, then you know you should probably disable those and kind of force these faster conversations. You see this at airports all the time. So airport network administrators would certainly use a tool like IPA to kind of check that type of information. IPA basically shows you these frame types here. They color them a little bit differently, and I'll go a little bit over these frame types. Management frames are your beacons, your probes, your probe responses. This is why these frames basically kind of help stations and Wi-Fi devices join and leave networks. This is why you actually want to turn Wi-Fi off on your devices, because 10 times a second or so, your Wi-Fi devices are basically saying, hey, I want to find this network. So if you leave your house and you disassociate from your Wi-Fi network, every other Wi-Fi network you've ever been to. So for me, I've been to the Boise airport Wi-Fi, and so my device will actually start sending out probe requests for the Boise airport. Hey, Boise airport, are you there? I want to connect to you. And any other Wi-Fi network that I've ever associated to, these devices start sending probe requests. And those are management frames. And even with access points, if your access point, about 10 times a second, your access point is saying, hey, I'm this network, I support these data rates, you can connect to me. So this stuff is constantly going on, and you're going to always capture these types of management frames. And it's kind of fun because you can glean a lot of information from these. For instance, I was talking about probe requests from a client device. You can actually see what networks they're looking for. And this is kind of what a lot of man-in-the-middle attackers will use. They'll capture probe requests from a device that's unassociated, and it can actually dive into this packet and say, oh, I see that this device is looking for, Boise airport. And so they'll then deploy a fake network that's with the same SSID as Boise airport, and then your device will try and associate to it and authenticate to it. And of course, they're going to leave it open. So then, boom, they have your device associated and authenticated to their own network, which they can then glean all the data from your device. So there's a lot of stuff you can do with these types of packets, and there's a lot of data in these packets, for good or bad, right? A lot of security issues with these packets as well, but that's just kind of how the Wi-Fi protocol is. IPA will also capture control frames. So these are actual frames that aid in the delivery of the Wi-Fi frames. This is a lot like walkie-talkie stuff. Basically, you have to acknowledge when you receive something, and you kind of request to send and clear to send, right? Roger, good to send, right? And then saying over when you're using a walkie-talkie is very similar to this type of stuff, so that the client devices or the access point know when the information is done being sent. And so that's kind of what control frames are. And of course, data frames are the only frames that go all the way up the OSI model. This is your actual, YouTube video data that goes all the way out to Google and back. And then QoS data is just quality of service, which means it's higher priority. So your voice, if you're having a video conference, your voice is going to be QoS data. It's going to be the last thing to get lost if you experience signal strength issues or interference. The video data will just be tagged as regular data, and that will be the first thing to go if you experience some Wi-Fi issues. So really cool to see this stuff in IPA. Typically, you have to use a tool like Wireshark to kind of see this stuff, but it's really hard to visualize airtime usage. You have to have filters, which are really difficult to implement, and these kind of color coding schemes, which again are kind of difficult to implement to really see what's going on. And that's where IPA comes into play. We use these multi-layered pie charts. And so basically, like this example here is, you choose one channel to scan. We'll say this is channel 1. Actually, it was channel 1. And this very first reading here is the network. So in this case, it was this Bronco Guest SSID, which this is at a college campus here in Boise. Go Broncos. And the next slice of pie out is actually the access point. So there was only one access point here on channel 1, and just immediately you can infer that this entire access point was taking up about half of the airtime on channel 1, right? Because you can kind of see this slice of pie. So you immediately see like what's going on channel 1 and who's taking up the most airtime. Next slice of pie out is the client device. So this may be an Apple device, maybe it's a laptop of some sort, but you can see about a quarter of channel 1 is being completely consumed by this one client device. Next slice of pie out is the actual frame type. And so if we go kind of to our little key here, we know that blue frames are data frames. So that same Apple device was eating up a lot of data, which is good. Maybe it was using a YouTube video or something like that with a very minimal amount of control frames to aid in the delivery of those data frames. And we don't see a lot of beacons or probe requests because this is a healthily associated client that already knows the network. Here's this little purple slice is probably the beacon from the network broadcasting that it's there, because remember, 10 times a second every access point does that. So you're always going to see this purple slice, at least a purple slice like this on a network, just because they're always beaconing. Right now, Microcom sells the Eye P.A Essential Bundle, which comes with this top left adapter. It's a 3x3 spatial stream adapter, so pretty much as good as you can get. You actually can get 4x4. There's no 4x4 adapter out on the market right now. So it's the most spatial streams you can capture, which means you're getting as much data as possible in monitor mode. And it supports the 2.4 and 5 gigahertz band, and it allows it to be captured directly in IPA and therefore Windows, which historically has just been a very expensive thing to do. Typically, Windows does not allow for native packet capture unless you have some sort of proprietary drivers or software like IPA. Mac OS does have a good packet capture adapter built into it. The MacBook Pro has a 3x3 spatial stream adapter specifically, and you can export PCAPs from Mac OS and import them into IPA for kind of further analysis or review, so to speak. And then some other sources, a lot of access points will actually spit out PCAP files. I'm sure you guys deploy access points like Aruba, Cisco, Aerohive. Those all produce PCAP files from their perspective, which are pretty handy to kind of see, what they're seeing from their perspective, which you can then import into IPA and kind of analyze for further review. And I'll kind of show you real quick what IPA looks like and what it has to offer. And maybe this is the tool you want to choose to learn more about packets, because it's a great learning tool as well. So once you hop in here, there's a few example files which I actually do really like looking at. The first one that's really fun is this virtual SSIDs example file. This was sent in from a customer of mine who had a virtual SSID, as you can see in the top over here, for pretty much everything, right? He had a student's SSID, staff SSID, VR, guest, BYOD, a second guest's SSID. And remember those beacon frames I was talking about, 10 times a second? Well, that's all that was happening here on this channel, right? And so if you just go out, these are all beacons. These are just virtual SSIDs saying, hey, I'm here, I support these data rates, you can connect to me. There's almost no actual data. There's hardly any clients. You can kind of see immediately right here in this active selection box. There's only 9 clients total and 34 SSIDs. So, it's pretty easy for me to kind of tell this customer, right off the bat, I said, hey, man, you got way too many virtual SSIDs. You don't need that many, and whoever says you do, that's a lie. Like, you really only need to have a couple networks and at least just 2 to 3 virtual SSIDs, no more than that, because your airtime is just getting completely consumed by this virtual beaconing of SSIDs. And with IP, it's just so easy to immediately see what's going on. A tool like Wireshark, you wouldn't actually really know what's going on too well. Maybe you'd see these beacons and know something's going on, but you wouldn't really be able to see the airtime, right? To be able to see how much it's taking up on this channel. So this was a pretty fun one to receive, to say the least. A really good example here is the streaming Netflix. This was one I took here at the MetaGeek office, and I think this was on channel 157, if I'm not mistaken. Yeah. So I took a packet capture on channel 157, and I pretty much there's this MetaGeek SSID, and then there was this WiFi management SSID, and let's just say I don't really care about the WiFi management. Maybe I experienced a client disconnect later on in the packet capture, because really that's what you want to do. If you're experiencing Wi-Fi issues, you really want to capture that. So maybe it was in the latter half of the packet capture, maybe it was over here somewhere. I'm able to quickly kind of filter to that point in time. And I know that I only want to focus on the MetaGeek SSID, so all I have to do is click on it, and now I'm only looking at the MetaGeek SSID. The next slice out is the access point. There's only one access point. We named it the Plank at the time, and so and maybe this is the Apple device that I want to troubleshoot. This was the actual Apple TV. This was my actual Apple iPhone streaming Netflix to the Apple TV, which is kind of fun to see how that worked in terms of data. But both were using a little bit of data, as you can see. These blue kind of slices out, but there was a lot, kind of fun to see these control frames here. A lot of control frames were needed to kind of airplay that data from one device to the other. So that's why you see a lot of these orange colored control frames here. Let's just say I wanted to troubleshoot this one Apple device. So again, I just click on it, and with a couple clicks, and you can even see in the airtime, this blue just represents this one Apple device's airtime versus all the other traffic, which is just awesome. And then over here on the left-hand side in the active selection column, here's my data rates that were being used. So about 69% of the time I was using 24 megabits per second, which is a good data rate. I would be satisfied with that as a network admin. And this type of insight is very valuable to know the speeds at which your devices are operating at. I even actually had a little chunk of time, about 27% at 173, which is just flying, right? That's really good signal strength. I would be very pleased to see that. But maybe we experience a disconnect or something, we'll just say for the sake of example. And so with just a few clicks, I'm able to filter down to that immediately, and then I can actually send this to Wireshark from the file menu. And Wireshark is where you can actually get down to the nitty gritty. This is great because it's really hard to filter in Wireshark. Eye P.A just did that for me with a couple clicks. Super easy if you're really exploring PCAP files a lot. You absolutely need a tool like Eye P.A. This is probably one of our more popular tools amongst the professionals, like the Twitter, people on Twitter really like Eye P.A. Their number one kind of request is that we get a Mac version, which we're certainly aware of that. I'm trying to work on a Mac version at this point, but right now it's Windows only. But again, then you can get into the nitty gritty and start looking at the flags and things like that. There's a lot of data you can glean in Wireshark from each individual packet. And then you can kind of figure out if it's a chipset issue or kind of what's happening there. But that's probably one of my favorite things about Eye P.A is that ability to quickly send down filtered results to Wireshark, which is pretty awesome. And then finally, the last thing I'll kind of showcase is we do try and kind of boil the data down. If we see something, we kind of have these flags here. So for instance, we did see a Apple device on that network that had a high retransmit rate, right? And so anything over like 3%, I think we flag it. And then we give you some solutions. So you don't have to be a Wi-Fi expert, to know what to do about it. You just got to read these kind of little solutions. Maybe it's, non-Wi-Fi interference. Maybe there's too many adjacent channels or something like that, or overlapping channels. And so kind of some tips here to kind of improve your Wi-Fi network. But it's kind of cool to kind of have this stuff boiled down for you. And we're working on this section quite a bit to get as much data into this section and boil kind of these insights a little bit more for you. So yeah, with that, I apologize for the little bit of battery delay and lack of drawing capabilities at the end there, but I think that's pretty much what I had planned for today. So Julie, if we have any questions, I'd be happy to answer them.
Yes, Casey, thank you so much for that presentation. We do have some questions. Let's get started with the first one. Regarding Chanalyzer, will it be able to support further upgrades of Wi-Fi signals?
Yeah, absolutely. Chanalyzer comes with 1 year of Medicare, and that's basically what allows you to get updates to the software. So if it happens within the first year, that's free of charge. And then each year after that, it's $100 to renew the Medicare on that key, which Microcom also offers Medicare as well. And so if, Wi-Fi 6 comes around and, you aren't able to get the update because it's after that first year, just be $100 to stay current and get the latest updates of Chanalyzer, which would be able to kind of show the Wi-Fi 6 stuff. And in terms of hardware, Wi-Fi 6, the Wi-Fi DBX is going to always be able to scan Wi-Fi 6 or 802.11ax data, things like that. I mean, it's already compatible with AX, but specifically when it comes to Wi-Fi 6E, which stands for extended, which stands for basically opening up the 6 gigahertz spectrum. Well, for that, you do need to have another hardware device. And MetaGeek is currently working on building that device out. And I'm sure we'll have some sort of upgrade path option for current DBX owners in order to unlock that 6 gigahertz scanning capability specifically. And that would be some sort of upgrade program that I'm sure MetaGeek and Microcom would offer to their users.
Excellent. Thank you very much. Next question here for you. Regarding Chanalyzer, do you need the Wi-Fi for Chanalyzer to actually work? Can you confirm that?
Yeah, so you actually do, and that's pretty much deliberate. There is a version of Chanalyzer, I think it's 5.9, where you actually don't need a Wi-Fi. It'll just kind of do Wi-Fi scanning and stuff. But that was kind of just a glitch that, I don't think it's necessarily something we're like driven to like only, you have to have the Wi-Fi, but Chanalyzer really does need to have the Wi-Fi to really get the full usage out of it. It was definitely designed around that piece of hardware. So kind of, to answer this question, I would just say simply yes, it does need to have a Wi-Fi plugged in order to really be used.
Thank you very much. Next question here for you. Is co-channel interference avoidable if you don't have access to an adjacent network?
It really depends on what's around you. Co-channel interference is where you share a channel with someone else, whether it's it's most likely a neighbor, right? A neighboring network. And so, it's only avoidable if you don't have a neighboring network on that channel. So you really want to avoid it if you're out in the middle of the boonies, right? If you're out in the middle of nowhere, yeah, of course it's avoidable because there's no networks around you. So you can place your network on 1, 6, or 11. But and if you're deploying multiple access points, maybe 4 access points, then at some point, you might have a little bit of, two access points on channel 1, since you go through 1, 6, and 11, but you want them to be as far away as possible from each other. So if you need to deploy, 2 access points on channel 1, you want them to be as far away as possible from each other. In terms of neighboring networks, it really just depends on what's around you and how many neighbors you have. If you're in any sort of busy suburban or downtown environment or neighborhood environment, you're probably not going to be able to avoid co-channel interference. You might not even be able to avoid adjacent channel interference if you have one of those neighbors that deploy networks on channels 2 or channels 3 or channels 7 or channels 8, right? Unfortunately, they kind of ruin it for everybody because they force anyone using channels 1, 6, and 11 to experience adjacent channel interference. But really just depends. If you can, you want to avoid all of them, but if you have to have one, co-channel interference is better than adjacent channel interference.
Thank you. Casey, next question here for you. Does Chanalyzer pull up information or items non-wireless that may be causing interference?
Yeah, you would have to have a Wi-Fi DBX to kind of check the spectrum, but yeah, that's what it's made for, is checking for non-Wi-Fi interference from non-Wi-Fi devices. If we're talking about Zigbee devices, for instance, if they're talking loudly or beaconing at all, with their own proprietary protocol, I'm not sure, I forgot what Zigbee is. It's like 803.1 or something weird like that, similar. Then the Wi-Fi DBX will see it and show it and kind of show if it's interfering with your Wi-Fi networks. But, Chanalyzer really only focuses on 802.11 protocol, which is Wi-Fi protocol. And so we're only able to see like signal strength and things like that, and MAC address and things like that because it's built into the Wi-Fi protocol. We wouldn't be able to analyze non-Wi-Fi protocol in that sense of seeing signal strength, but the Wi-Fi DBX is just a raw spectrum analyzer, so it's going to catch everything that's talking on the 2.4 or 5 gigahertz bands, Wi-Fi or non-Wi-Fi. So yeah, good question.
Thank you, Casey. Next question. Yeah, thank you. Next question here regarding Report Builder. Is this part of the device software or is an additional cost feature?
Right now, it's baked into the cost. It used to be a separate feature. So if you purchased a Chanalyzer 5 license many years ago, there's a chance you didn't have that accessory, which you can then add on. You just need to reach out to Microcom or MetaGeek. But if you purchase a new license today, it's going to be built in. We don't sell it standalone anymore, and therefore neither does Microcom.
Excellent, thank you. Next question here for you. Regarding Wi-Fi Air, what would be the warranty on this device?
Yeah, basically, if it's faulty, we'll replace it within, we'll work with you on that. I think our official policy is 45 days, so I'm not gonna, extend our policy beyond that, over a recording. But if it's a faulty device and it was faulty from the get-go, we'll work with you very generously on that. and so will Microcom, therefore. But we have a pretty good 45-day policy. If you purchase through Microcom, you probably have to make sure, whatever Microcom's policy is as well, make sure it's good with them, as they are the official reseller of that device. But again, if it's faulty from the get-go, we'll replace that for you, no problem. So.
Excellent. Thank you so much, Casey. Can you remind us where all MetaGeek products are manufactured?
Yeah, they're actually, so the WiSpy DBX is manufactured just in a facility a few miles away from us. We're in Boise, Idaho. This is in a place called Meridian, which is basically a suburb of Boise. So we actually, manufacture everything right here locally. WiSpy Air is a little bit of a different story. We partnered with a company called Osseum, and Osseum, I actually don't know where they're based out of. I would be lying if I said a state right now. I'm not sure where they are, but they're pretty close. I think they're in like Colorado or something like that. So all locally within the United States, and the DBX hardware is manufactured just right in our backyard here in Boise, Idaho.
Thank you so much for answering all of those questions for us. And thank you to everyone for attending today's webinar. And if anyone has any further questions, please feel free to contact your sales rep or email us at sales@microcomtech.com. And please remember, this webinar presentation has been recorded and will be uploaded to our Microcom YouTube channel so you can view it again. Casey, appreciate your time and all of that valuable information today. Thank you very much. Have a wonderful day, and until next time, we will talk again.
All right, thanks, Julie.
Bye-bye for now.